A bare helium nucleus has two positive charges and a mass of 6.64 times 10 negative 27 kilogram. Calculate its kinetic energy in joules at 2.00% of the speed of light. You are given a charge, two positive charges. So Q is going to be twice a unit charge, which is 1.6 times 10 to the minus 19 coulomb. And we are also given the mass, 6.64 times 10 to the power of negative 27 kilograms. And S says calculate the kinetic energy given the velocity. So velocity is given in terms of the speed of light, 2.00% of c. And we know that the speed of light is 3 times 10 to the 8 meters per second. Therefore, 2%, which is 0.02 of the speed of light, which is 3 times 10 to the 8 meters per second. And that speed is equal to 6 times 10 to the power of 6 meters per second. So we know the speed. And what we are asked to find is kinetic energy. And we know that kinetic energy is half mv squared. So just plug in the numbers. Mass is given to be 6.64 times 10 to the minus 27 kilogram. And the velocity, which is calculated from the speed of light, is 6 times 10 to the 6 meters per second squared. And that yields 1.20 times 10 to the power of negative 13 joule. And B, what is this in electron volts? We are asked to find the kinetic energy in electron volt. Alright, so we know that one electron volt is equal to 1.6 times 10 to the minus 19 joule. All you need to do is just convert this to electron volt. To do that, we have the kinetic energy calculated in A. That's equal to 1.20 times 10 to the power of negative 13 joule. So we need it in electron volt, so we multiply it by 1 electron volt. And divide by 1 electron volt equivalent joule, which is 1.6 times 10 to the minus 19 joule. If joule goes with joule, we are left with electron volt for the unit. And that yields 7.47 times 10 to the power of 5 electron volt. See, what voltage would be needed to obtain this energy? We are asked to find what voltage to get this energy. And we know that the potential energy must be equal to the kinetic energy, because if no energy is lost, the potential energy initial will be equal to the kinetic energy. And we know that potential energy of a charge is given by Q times V, where V is the potential difference, and potential energy and potential difference are related. Potential energy is equal to the charge multiplied by the voltage. That's equal to kinetic energy. So if no energy is lost, the voltage times Q will be equal to the kinetic energy, and therefore voltage will be kinetic energy divided by the charge. Plug in the numbers. We have already calculated the kinetic energy in A, and that's equal to 1.20 times 10 to the minus negative 13 joule divided by the charge, which is twice the unit charge, 2 times 1.6 times 10 to the minus 19 coulomb. Joule per coulomb is volt, so you have V or the unit, and the calculation yields 3.75 times 75. 3.75 times 10 to the power of 5 volts. So to get this kinetic energy for twice the unit charge, we need potential difference or voltage of 3.75 times 10 to the 5 volt.